My name's Jonathan Hicks and we're looking at decimals. What are decimals? Where do they come from? Now, a word of warning to our European viewers. In England, if we have a decimal number like 3.4, we write it with a dot in the middle here. Not at the bottom, notice it must be in the middle. Whereas in European countries and a lot of French-speaking countries around the world, they tend to write decimals like that. So that would be 3.4. But as I say, I'm going to write it with the dot, so if you're not quite sure what the dot is, you might be used to it writing like that. By all means write it like that, that's fine. It's just that I'm going to do it that way. Now, before we get going, I'd like to ask you a little question, a puzzle if you like. We're going to count. But instead of counting 1, 2, 3, 4 in the usual way, I want to count here in decimals. So I'm going to start with 0.1 and I'm going to keep adding 0.1 each time. So 0.1, 0.2, 0.3, etc. You get the idea. We're going to keep going until we get to 0.9. So 0.7, 0.8, 0.9. My question is, what comes next? 0.10? Have a think about that one. We will come back to that a little bit later. Fractions are much easier to understand generally. They're far more intuitive than decimals. Let me show you what I mean. Imagine you have a pizza or a cake or whatever your favourite circular food is. And if I split it into 4 and I eat one slice of pizza, you can see I've eaten 1/4 of the pizza, and understanding how these numbers connect to the real life object is fairly straightforward. The number on the top is the number of slices you've got or you're eating. The number on the bottom is simply how many slices there are altogether. So you can see directly how these numbers connect to the real life object. As a decimal though, many of you will realise 1/4 is 0.25. It's much more difficult to see how this connects to the real life object. Now, decimals are very useful in certain situations, but generally in maths we do prefer fractions. They're often easier to deal with. Many of you probably won't think that right now. We'll come on to that at the end. But what I want to do in this video is to try and explain where these come from. Why are decimals the way they are and how do we use them? So, the first thing you need to realise is that decimals were invented by man. A long time ago, some clever mathematical types came up with this system. And you need to realise that 0.1, the decimal here, is defined to be 1/10. There's no mathematical proof that will get you from there to there. It's just by definition. If you think about the places, as in the place value, the columns that these things are in, you've got no units here, and you've got one that's in the tenths column. So that is 1/10. 1/10, by definition. If you're not sure about place value, the whole columns thing, go and watch the place value video, and that will lay them all out for you in a way that hopefully you'll be able to remember. But the point you need to appreciate here is 0.1 is 1/10 by definition. Equally, if I've got a decimal like 0.3, that would be 3/10. I've got no units and 3/10. It's in the tenths column. 3/10. Just by definition. If we had 0.01, no units, no tenths, the next column over is hundredths. So you've got 1/100th. So again, by definition, this is the same as 1/100th. There's no maths that gets you from there to there, it's just a definition. So if we had 0.07, that would be no units, no tenths, 7/100ths. So as a fraction, you would write it like that. Let me do a slightly different example. If we had 0.39, here I've got 3/10 and 9/100ths. So you could write that as 3/10 plus 9/100ths. It's the same thing. If you were to add the fractions, you're just going to get 39/100ths here. If you're not sure about adding fractions, you can go and watch the fractions video. But the point here is simply that 0.39 can be written as 39/100ths. And it's because it's the same as 3/10, 3/10 plus 9/100ths, 9/100ths. So the places that the numbers sit in, the columns, give you the value of the decimal, and it just translates directly to fractions. So that's where they come from, if you like. They've just been invented by people, and they're defined to be the way that they are. All right, let's come back to this counting thing, see if we can make sense of it. Now, first of all, before we look at that one, I want to show you how counting works. Now, don't get me wrong, I'm sure you know how to count, but you've probably never really thought about how it actually works. What's going on when we count? If you think about it, now I'm going to start with 0 here. Technically, if you count, you should start with nothing. You've got nothing to start with, and then you count 1. There it is. 2, 3, and we know how to count all the way up to 9. Now, originally there was a slight issue here. These little squiggly things that I've written here are symbols that have been created to represent numbers. This curly thing here represents the number 3. It represents 3 in English, but in different languages they use different symbols depending on what the language is. So Chinese, for example, uses different symbols to represent 1, 2, 3, 4. But in English, these are the symbols we go with. And you keep going, there's a different symbol for each number until you get to 10. Now when you get to 10, we run out of symbols. There aren't any more symbols than this. There are only 10 of them. You've got 0, 1 to 9, and that's it. 10 symbols to do all of your numbers with. There's no extra symbol for 10. We reuse the symbols we've already had when we get to 10. And the way it works is you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 9 rolls over to a 0. So the 9 becomes a 0, and whenever a 9 rolls over to a 0, you have to add 1 onto the next column. Now, this is the units column, which means the next column here is going to be the tens column. We've got no tens, no tens, no tens all the way down, so if we add 1 onto nothing, you just get a 1. So the 9 rolls over to 0, and you add 1 onto the next column. Let me carry on from 10 up here so you can see it. So 10, 11, 12, 13, etc., 18, 19. What happens is the 1 stays the same all the way down. 1, 1, 1, 1, 1, 1, 1, 1, 1. And you just keep cycling through all your symbols again. All these symbols we created. 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you get to 9, the next one we've run out of symbols, so the 9 rolls over to a 0. Whenever the 9 rolls over to a 0, you add 1 onto the next column. So that's going to become a 2. Then the 2 stays the same all the way down. 2, 2, 2, 2, 2, 2, 2. And you just keep cycling through your symbols again. 0, 1, 2, 3, 4, etc. And you can see you've got 18, 19, 20, 21, 22, 23. That's how we say the numbers. But what's happening is, if we carry on, 28, 29, is you cycle through the symbols. When a 9 rolls over to a 0, then you add 1 onto the next column. And the next column will never change. It will stay the same all the way down until a 9 rolls over to a 0. Only then will it change. And you can keep going until you get to 98, 99. At this point, the 9 rolls over to a 0, and so you add 1 onto the next column. But that's a 9 as well, which means that's going to roll over to a 0 as well. And because this 9 rolled over to 0, you have to add 1 onto the next column. And the next column here is going to be the hundreds, so you end up with 100. Everything else then stays the same. These will all stay the same again, and you will cycle through your symbols again. 1, 2, 3. Now obviously, as I say, I know you know how to count, but that's what's actually going on. You cycle through all your symbols. When you get to a 9, it rolls over. And you just leave the rest the same, exactly the same all the way through. It's only when a 9 rolls over that you need to change anything else. And if 2 of them roll over, you just keep changing the next one until it doesn't roll over anymore. So that's how it works. And with decimals, it works exactly the same. So let's have a proper look at this now. We started with a 1, 2, 3, 4. You cycle through all your symbols, and when you get to a 9, it rolls over. The 9 becomes a 0. The decimal point will stay there, but then you add 1 onto the next column. So the next number, after 0.7, 0.8, 0.9, it's not 0.10, it's 1.0. Or is that a 1? Let's have a little look at that. Let me just clear this first. So, 1.0. Is this the same as 1? Well, You've got 1 in your units column here, and you've got 0 in your tenths column. 1 unit and no tenths. Well, if you don't have any tenths, that doesn't do anything for you, so it may as well not be there. And in fact, if you don't have anything after the decimal point, you don't need the decimal point either. So yes, 1 is the same as 1, or rather 1.0 is exactly the same as 1. So I don't need to write the 0.0 here. But it's not wrong to write the 0.0. You can put the 0.0 there if you want to, but you need to appreciate that this is exactly the same as 1. Zeros after the decimal point don't do anything. Just quickly on that point, if I have a number like 34.5, lots of zeros, just to make this clear, so tens column, units column, tenths column, I've got 5 tenths, but then I've got no hundredths, no thousandths, no 10,000ths, so you don't need any of those. You never need zeros on the end. But if you have a number like 34,500, so it's almost the same kind of thing, but this time my decimal point is going to be right at the end here. We don't bother writing it, but that's where it is. I need these zeros. Zeros on the left of the decimal point, you do need them, because this is 34,500. If I get rid of them, suddenly it's 345. It's not the same number. So just be careful. Zeros on the end of a decimal number, fine. You don't need those, get rid of them. But if they're higher up here, on the left of the decimal point, you must keep those. It keeps the place value of everything else. Alright, so we've learned how to count up 0.8, 0.9, 1. Let's see what happens next. Well, if we're counting, it means these are going to stay the same. So I'll put the 1.0 up here. It's going to be 1, 1, 1, 1, 1 all the way down. Decimal point won't change. And you cycle through your digits. So 0, 1, 2, 3, etc. Keep going till we get to 1.9. Then the 9 will roll over to a 0. And you add 1 onto the next column. That becomes 2 or 2.0. They're both the same thing. Carry on. You'd have 2.1, 2.2. And you keep going. Whenever the 9 rolls over, that's when you add 1. Otherwise, these will stay the same all the way down. Now that was adding 0.1 each time. I'd like to do something slightly more difficult now, which is starting with 0.01. So instead of a tenth, adding a tenth each time, we're going to be adding a hundredth each time. So it's 0.01, 0.02, 0.03, etc. 0.08, 0.09, and then the 9 rolls over to a 0. So that becomes a 0. That, then, you add 1 to the next column, the 0 becomes a 1. Don't mess with anything else. You only add 1 onto the immediate next column. So 0.01, if you keep adding in those after 0.09, you get to 0.10 or 0.1. Well, the 0 on the end doesn't do anything. We just saw that over here. So actually, that is the same as 0.1. Again, it's not wrong to write the 0, and it might be helpful sometimes when you're lining your decimals up to stick the 0 in, that's fine. Just be careful about reading this as 0.10. If you read it as 0.10, you're inclined to think that that's in the tens column somehow, and it's not, it's the tenths column. Just to give you another quick example, because this is very important. If you had 0.347, you can't read this as 0.347. Otherwise you'll think this is a hundreds and a tens and a units, and they're not. This is tenths, hundredths, thousands. It's completely different. So be very careful about that. So we've counted up 0.09, 0.10, you could say, or just 0.1 if you want. And then we carry on. This stuff stays the same. So 0.1, 0.1 all the way down. And then you cycle through your symbols again. 1, 2, 3, 4. Let's go up here. 0. Let's do 18. 0.19. The 9 rolls over to a 0. You add 1 onto the next column. Nothing else changes. And then you can carry on. And you're going to get a 2 all the way down. Alright, hopefully that's given you a much better understanding of how decimals work. If you can understand and realise that they just correspond to the columns that they're in, the place value, it's much easier to work with. So you've got 1/10 here, 2 hundredths. No units if you like. That's the way you need to think about decimals. So in terms of counting, when you're adding or multiplying, if you're aware of the place value, the column that each of the digits sit in, you'll find it's a lot easier to work with. So finally then, just wanted to say a quick word about fractions and decimals. We looked at the slice of pizza from before. We were writing it out as a quarter. Let's just get that back again. There's my rather large quarter. So that's a quarter, and we could write it as 0.25 as the decimal. Now, as we've seen, this means you've got no units, 2 tenths, and 5 hundredths. So this would be the same, I'll write it here, as 2 tenths and 5 hundredths. Now again, if we add the fractions, don't worry too much about this. Look at the fractions video if you want to see the details. You're going to get 25 hundredths, and we can then cancel that down, and it will cancel down to a quarter. Hopefully you can see 25 as a quarter of 100. If you've got 25 out of 100, you've got a quarter. So you can see that decimals are the same here as the fraction, and that's why. It's because this is 2 tenths, and 5 hundredths. And when you combine them, you can simplify that to a quarter. But they are less intuitive, and for that reason I do prefer fractions. In general, in maths, we always prefer fractions actually. You should leave your answer as a fraction whenever possible. If the question you're given starts off with decimals, leave your answer as a decimal. But if it's some other context and they haven't said whether or not you should leave it as fractions or decimals, generally you should leave it as a fraction. A lot of students, I find, if they have the choice between writing 0.25 or a quarter, go with the decimal one. And it's because they have this fear of fractions. They've always struggled with fractions, they never quite got how do you multiply, how do you add, and all the rest of it. You really need to get your head around fractions. If you can master fractions, you'll find it makes a lot of other things in maths much easier. Fractions are especially important for algebra. So if you want to tackle your algebra, you need to be confident with fractions. Go and look at all the fractions videos if you want to get your head around that. Decimals can be very useful in certain situations. Obviously, if you're working with money or something, you need to be working in decimals, not fractions. But most of the time in maths, particularly in algebra, we always prefer fractions. Alright, hopefully that's given you a good overview of decimals. You've understood some of the key concepts that are underlying what's going on there.